For this problem, I would like you to try it on your own first. So please pause the video now and try this problem here on your own. It still uses fruit flies, but we're just crossing two heterozygous flies this time. And when you are done, play the video and you can watch how it's done to make sure you've done it correctly. So pause it now. Okay, now that you've tried the problem, let's go through with our steps. Remember, once again, we said that big B was going to be for brown flies and little b was going to be for yellow flies. In this case here, our parents are different. They're both heterozygous. Now, I don't tell you what color it is. However, you don't need to know if it's brown or yellow because heterozygous always means two different letters. So one big B and one little b for each parent. Now, because they have one capital B, they'll both be brown, but I didn't tell you that in the problem. Now, in step 3, we make our Punnett square. You should have your allele separated by parent, and checking your work, you should have a Punnett square that looks similar to mine. Step 4, when you're labeling your genotypes, I'm just going to abbreviate it with the word geno, we need to label that there are actually 3 different genotypes that we see in this Punnett square. We see capital B, but we only see one of those. So we need to label 1 out of 4, capital B, or you could say 25%. We see 2, capital B, lowercase b's. So you could say 2 out of 4, you could say 1/2, or you could say 50%. And then we have 1, little b. So you could say 1 out of 4 or 25% little b's. Now question number 5, we always have to label our phenotypes. Now this is interesting because we have 1 out of 4, capital B brown, but we have 2 out of 4 that also have a capital B, so those would also be brown. That means we actually have 3/4 or 75% brown flies, and we have 1/4 without any capital B's, so we have 1/4 or 25% that would be yellow. So when it's asked, what is the chance that they will produce yellow flies? There's a 1/4 chance, and that's the actual answer to the question. Notice, both parents were actually brown, but they were still able to produce yellow offspring. The only way that this is possible in nature is if the parents are both heterozygous for that trait, because they could each pass on their recessive allele with a 25% chance that their offspring are going to have that trait. Now remember, this is just a chance. It's not always going to happen, but there is a 1/4 chance that they could have a yellow offspring.